Okay, let's start today's session. So I'm sharing my slides. Just a minute. Someone please confirm if my screen is visible.
Yes.
Yes, ma'am.
Okay. So today our topic is supply chain management, and I have explained it in a simplified way. So let's understand it. So the key takeaways will be like we will be knowing like what is supply chain management, a kind of overview. We will see different case studies, some success stories, and like some examples where due to supply chain, like not proper supply chain, the companies have failed. And what is quality control and PLM? PLM is product lifecycle management. So these two are the very key terms in supply chain management. And the role of SCM analytics. So this is very important in today's world. And at the end, I will take up the questions. Okay, so introduction of supply chain. So by simple definition, SCM includes all activities that turn raw materials into finished goods and put them to the customer hands. So this is a simple definition. So basically right from the raw material supplies to the manufacturing units, to the production warehouses, to the inventory places like inventory management places, and still the like the distribution happens through different logistics to the to the end customer. So till that point, everything includes in the supply chain. So everything is included. So it is kind of a comprehensive process which explains the chain of activities which is happening from the right from the just supplying of the raw materials, like procuring the raw materials, building the product, and distributing it to different channels to like till the customers receive the product. So it includes sourcing, designing, production, warehouse, shipping, and distribution, as I mentioned. The goal of SCM is to improve efficiency, quality, productivity, and customer satisfaction. So we will as we go deep dive into the slides, we will see why SCM is so important, and we will see why these goals, the objectives of SCM is so important to to sustain in a business. Okay. So as you can see from this diagram, the product moved from the supplier to the factories, then the product, the raw materials are basically assembled or turned into the end finished product, finished goods. Then they are moved to the warehouses, to the outlets, and to the consumers. So this is kind of a linear kind of a flow which you are seeing, but this is actually not so simple. Like pictorially, it can be represented like this, but it is not actually so simple, because we will see a lot many times that there will be multiple raw material suppliers, like tier 1, tier 2, tier 3 suppliers. There are multiple production houses, so different production houses will be actually producing different component of the finished product. There can be multiple finished good like the distribution channels, and there can be multiple end customers. So the network is really very complex, and maintaining the management over this network is really very complex thing. So having a proper supply chain in place actually reduce loss of operation costs, so that we will see in our the following slides. So why supply chain is important? Supply chain management, SCM, is crucial in today's competitive business because it directly impacts a company's ability to meet customer demands. So this is a very important point, because through supply chain, mostly the demands are forecasted, and as per the demands, the production is made. So it is a very crucial point here. It controls the cost, it improves overall efficiency. Effective SCM ensures that right products are delivered to right location at the right time and cost, fostering customer satisfaction, reducing waste, and enhancing profitability. So let's see some case studies. So I hope you have heard about this company, Toyota. Have you heard about the just-in-time production? What is JIT? Anyone?
No.
Okay. So let's just see that what Toyota did, like back in basically the World War II situation. So let me just tell you a story over this. So just imagine that, like that time period. It's post-war in Japan in the 1950s, and Toyota, a very small car company at that time, is trying to compete with American giants like Ford and General Motors. But Toyota has a big challenge. First of all, it has limited resources. Secondly, it is from a land which is, like prone to natural calamities and disasters. Mostly, it is a Japan. We know like there are frequent earthquakes happening. So, unlike its competitors, Toyota can't afford to keep huge stockpiles of parts and materials and like just sitting around. So it's basically, like they have this problem of, like this inventory management. So they can't take the risk of, like storing this, like huge stockpiles of the different parts and materials, and kind of, like if there is no supply coming, or there is no supply happening, there is no demand coming. So they innovate with a solution that's both kind of a, like an innovation and a groundbreaking for that time. It is a Toyota's production system, a model that would later become globally as a lean manufacturing or just-in-time production. So what they did is, like under that system, Toyota introduces an approach that's simple, that is very much simple, but kind of, like they didn't, basically waste the inventories, we can say, in that, like that model. So instead of manufacturing large amount of inventory in advance, they begin ordering parts only when they are needed for the assembly. So this way, parts flow in the Toyota's production line just in time to be used, minimizing storage cost and avoiding risk of excess inventory piling up. Okay, so what they do, like when there is a, like demand arising, they will just, take the supply of the raw materials. They will just assembly all the parts, in their production houses, and they will just, supply that. So that actually reduces lots of, like inventory management, and like inventories piling up, that is reduced. And they used to do it with precision. In just kind of, they tell that it is kind of in 5 days period they finished everything. So it is kind of, they practice with precision. That's why, like we talk about Toyota's quality and Toyota's JIT, like model so much. So it's a gamble, but Toyota's vision for a streamlined, efficient production line pays off basically. So this method becomes Toyota's key to success, and over the years, it allows them to grow from a regional player into a world player, basically into a global player, and competing with most of the respected car manufacturers in the world. So Toyota is now, I think, one of the, like key player in this market. So another example is Zara. Anybody heard about this name, Zara?
Yes.
Anyone? Yeah. So basically, it's a fashion supply chain, and like how they, like optimize the supply chain, and kind of, like always become one step ahead. Okay. So what they did actually is, it is a Spanish brand that revolutionized the industry by creating what's now called fast fashion. So it all started in 1980s when Zara's founder basically decides he wants to break away the typical fashion calendar, where brand release in basically, like twice in a year. He envisioned that it should be coming in almost every week, like the new collection. The release of new collection should be coming in almost every week. So to make that vision a reality, Zara designed a unique supply chain strategy that prioritizes their speed and flexibility above all everything else, basically. Instead of manufacturing far away, Zara used to keep its production very close to, like home, with factories in Spain and nearby countries. So this allowed them to quickly respond to the latest fashion trends. Designers also used to, like walk alongside production teams, and as soon as they spot a new trend, whether it's on a runway or street or a social media, they can create it immediately. So within days, the new designs are in production, and within a couple of weeks, they are on the store shelves also. So with this also, they actually, like created a kind of a pool marketing, where the customers of Zara know that this fashion won't be staying for long, and actually, like that actually created lots of demand for them. So this is kind of, like optimizing the SCM, and they have always, like managed their inventory in a very smart way. Now you know about these companies, Walmart and Amazon. So they actually uses advanced data analytics to track, like Walmart I'm talking about, to track their sales and inventory, and even Amazon. So they are actually now, even Zara, Walmart, Amazon, these companies nowadays, like they are using the advanced data analytics basically to, like forecast their demand, and like on the real time data analytics, they are actually, like managing their inventory and the supply chain. So all these companies are success stories, like how they have, like smartly, like build their supply chain strategy. Now, there is a key failure also, like one of the failures being KFC. So, this is a story. So, in 2018, KFC in UK faced a supply chain failure after switching logistic providers. The transition led to severe delivery issues, causing around 800 KFC outlets to close temporarily due to lack of chicken. So, the incident received widespread media attention and had a significant negative impact on KFC's reputation. So the failure highlights how crucial and reliable SCM network is to maintain a business continuity, especially for companies in the food industry where timely deliveries are critical. The incidents led to millions in losses, damaged brand reputation, serving as a cautionary tale of how a single SCM error can impact on the entire network. So this is again kind of, like how improper supply chain management actually, like can disrupts the business continuity. Okay, so let's know what is quality control. So this is a very, like important terminology in the entire supply chain management concept. So quality control is something which should be done at every level of supply chain to ensure trust and authenticity of the product. So in supply chain management, it's a process that ensures products meet quality standards throughout the supply chain, kind of right from, like checking the quality of the raw materials until it is assembled and kind of the finished product is built. There also the quality check is very necessary until it is distributed through different channels and then to the end user by like after reaching the end users. So it's a key part of the global supply chain management and is important for maintaining customer satisfaction, reducing cost, and achieving operational excellence. So this theory I am not telling from myself. This is a theory in practice. And if someone is doing, like the courses like MBA and all, management and all, so these subjects are being taught. The supply chain management, inventory management, quality control. So kind of we have studied that it is kind of a practice which is needed in all the levels of supply chain. So that, like the product authenticity and product actually meets the quality standards. So the key aspects of quality control here is quality standards. As I said, that there will be different quality standards for different products, and also like what is a performance target, like what will be their key value, so that which will tell that okay, this product is of quality. Quality control methods. So there can be different quality control methods as well, such as testing, inspection, ensure that product meets a specification. Real-time data, so use of real-time data to catch and correct issues immediately. Risk assessment, so basically identify the potential risks and develop strategies to reduce them, like to develop the mitigation factors and all, like how to, like reduce the risk. Crisis management, so always having plans in place, like if one plan fails, then if any disaster happens and there are like with the quality issues, then like there is always a substitute plan. So these are all actually coming in the strategy of the supply chain basically to do the crisis management. Regulatory standards also ensures like the product should comply with regulatory requirements and standards in different countries. Customer satisfaction, meet or exceed customer satisfaction to lead customers loyalty. So these are different like checks which are like the key factors of the quality control. Now, this is a very important term, product lifecycle management. So what is product lifecycle management? So we have seen three terms basically, and integration of the three terms, like we have to ensure like all three things are working like in a proper manner to ensure that there is a proper supply chain network. So PLM is basically, like that manages all information and processes at every step of the product or service life cycle across globalized supply chain. So basically, it traces everything about the product, like right from where it is manufactured till like it reaches the end customers, everything like how the quality control is being done, quality, what are the quality checks, what are the quality parameters, where it has been tested, who has tested, who are the suppliers of the raw materials, where it has been stored in the like the warehouses. So everything, every details of the parts, items, like every documents in that chain basically. So that actually like constitutes the PLM. So again, it's a very, very crucial stage or crucial, I will say, process in this entire supply chain network. Now having having known now the at least the overview of supply chain. So there are three factors we can see in supply chain. The first one is data, the second is product, the third is money. Now, if I ask a question like, what is the flow of data? Whether it is from the manufacturers or from the beginning to the end customers or from the end customers to the manufacturers. Anyone?
First it will be from customer to the supplier. Then it will be flow backwards from supplier to the customer.
Okay,
Means data both-sided, means bi-directional it should be.
Okay, so basically, see the data. Basically, like data flow from customers to the suppliers is actually like relevant for the network. Definitely, the data is bi-directional because if the manufacturing is launching a new product, then they do lots of like promotion and advertisement. At least to make customers aware that this product is coming into the market. So it is kind of like the data flow from the manufacturers to the customers. But what is relevant in supply chain to understand the demand, like where the demand lies, what is customer preference, or like which product is getting sold in which time of the year. So like when the demand is increasing, at which place, like as per the demographics also, like which region is like seeing like the most demand in certain kind of product. So all this data basically like collected from the customers, like because like supply chain is all about like giving a decision to the companies that when like you start manufacturing, when you will procure the raw materials, how you will like identify your distribution channels, kind of which time of the year you will produce more. So all this kind of like different decision making things, it is coming from this real time data which is flowing from the customers, right? So this is one thing. Second is product. So product is definitely flowing from the manufacturer to the customer. Is there any instance that it is a bi-directional flow as well? Any example? Anyone? Okay, nothing coming up. Okay. So basically, when you are returning something, you don't like a dress. You have ordered a dress, but you don't like it. Okay. So, or any other product which is kind of, like the product is not in good, any food item you have ordered, but it is kind of stale. So it is not fresh. So anything which is, like getting returned in the same network, right? To the manufacturer back. So this is again, I kind of, like another example can be, the circular supply chain, what we call is like the what you say is reusability, like say the bottle cans, the basically the soft drink cans and all that get reused. Okay, so there are certain things, maybe the books, the papers, these get reused. So the any iron product that also get reused, like we sell it kind of if it is old and all. So these kind of products also get like returned to the manufacturer or the people who are actually like reusing, kind of like making like again they are recycling the product, so there it is getting returned. Okay. Money is basically flowing in all the section from the supplier, like who is like procuring the raw material, so from raw material to the manufacturer. If they are like using any warehouses, so there also it is flowing. Then different distribution channels, so wherever they are like using the shipment and logistic services, So wherever the use of services is there, any dealings is happening, so their money is involved. Okay. Now, when we talk about data, so data basically, like is a very strong point in supply chain network. So building a strategic supply chain network, we need lots of data. Now, different types of supply chain analytics can be descriptive, like I have given some examples also, like which events have happened, like sales jumped by 20%. Diagnostic, why this event has happened. So maybe there are some holidays that push the sales. Predictive, what can happen, like the sales will increase by 10% more next week. Okay, so kind of you're doing some prediction. Prescriptive, what should we do so can I like refill the store tomorrow. So kind of like it is telling that what kind of like analytics actually asking what kind of questions, and maybe probably the last end result you can see that what should we do, that is the main thing. Basically the business is taking some decision. So what decision needs to be taken there, like to like to for their better like the profit, kind of like better sales and all. So that is a like for better decision making, kind of like supply chain analytics is very important. Now, role of SCM analytics. So first and foremost thing is demand forecasting. So it is kind of like it's a very crucial factor, that use of historical data and trends to predict future demands. We will see also one like how we are like simulating demand, like forecast demand and all. Then inventory optimization, so balancing the inventory levels, that is also kind of like like it is a very crucial thing to like what we do in the supply chain analytics. Okay. Supplier performance analysis, like how the supplier is performing. Okay. Then risk management, so lots of risk can be predicted like with the analytics. Cost reduction, so pricing also can be done with the proper analytics in place. Then operational efficiency. So basically it identifies the inefficiencies and bottlenecks. Logistics, like what I said the other day, like the route planning, fuel efficiency, reduces transit. You can have the weather data, like whether the weather is good at a certain point of like certain point of the year when the shipment is happening. So lots of decision making comes here. Quality control. So it monitors the quality. Sorry, it monitors the quality across the supply chain, customer satisfaction. So we can actually have some key identifiable factors like KPIs, which we call key performance indicators, like what is the customer turnaround time, retention, customer retention percentage. Okay, whether customer is leaving and like stopping using your product and going to some other product, and what is the reason. So there are so many factors which you can like will give you the customer satisfaction index. Basically sustainability and compliance, so tracks the reduces of environmental impact. As I said, the circular supply chain, where we can do the recycle of the end, basically the finished, or what we can say, that left out thing basically. So that is also like that is also can be tracked with the analytics. So all these things are very important. So I will say only one thing over here. So with analytics you can take like number of decisions in this network. It is not only the demand prediction, but also there are so many things which you can actually do with the analytics in place. Now this is the demand statistics. So you can see this is a very interesting one. Just 1 minute. Okay, so you can see here the different like the industries, basically the verticals. So you can see the automotive and transportation, industrial equipments and heavy machineries, aerospace and defense, IT and telecom, semiconductors and electronics. So how this life cycle management market means, what is life cycle? I said the kind of like tracing the product from starting, like how it is being built, how the quality has been done, and everything to the end customers. So there is a huge market to like the solutions which are giving this kind of product life cycle, kind of like you can trace the product life cycle, so you can have a better product life cycle management. So and see the industries also, like the most pertinent industries and the kind of the growth. It is 8.0 CJER, like the annual growth rate from 2023 to 2030. And in 2021 it was 8.1 billion USD. So kind of it is growing. So you can see that the industries, how it is crucial for the industries to like trace the product right from the like the from the manufacturing house till the customers. So this is the like the trend says it all basically. Okay. Now going to the very interesting part of this session, and that is this is the last session. I will take some question. Any questions so far? Okay. Now let's understand this. Like I have done a like a very um, simple simulation here. Okay, so that everyone understands this. So kind of, and there are different ways to forecast demand. This is just one way. So I have used Monte Carlo simulation here. Okay, so kind of to do the demand forecasting. So here the problem statement is a mean of the demand of a product cell is as given as 500. So this is a mean of demand with a standard deviation of 50. Okay, so the mean is given as 500 and standard deviation is given as 50. Now, do you know what is mean and standard deviation? Anybody having question? I can explain.
No, ma'am.
Okay, so let me just explain and just give a one-liner. So basically, if your product demand, like there are like you are just seeing the demand of your product like in a different months of the year, let's say 450, 470, 480, 550. So based on your data, the mean is given as 500. So this is kind of the average demand which you are getting for your production. This is clear? Okay. Now the standard deviation is 50. Standard deviation is 50 means it can be plus minus 50. Basically, it can be deviate and it can be like the topmost can be 550 and the bottommost can be 450. So it can be plus minus 50. Okay. Now it follows a normal distribution. So the demand follows a normal distribution. Okay. The following costs are given as administrative cost as this, like what is this? 400,000 USD. Advertising cost is 600,000 USD. Labor cost 450 USD per unit. Parts cost 1,000 USD per unit. Selling price is given as 3,500 USD per unit. So these are the different costs which are given. Okay. Now simulate with random probability in this context to understand how fluctuations in demand impact operating income and other key metrics. Okay. So what is operating income? Operating income formula is given here. This is basically total revenue which is happening minus total variable cost plus total fixed cost. Now, can anyone say what is variable cost and fixed cost here?
So that labor cost and parts cost.
Labor cost and part cost is variable cost.
Yes.
Okay. So fixed cost is definitely administrative cost and advertising cost because this is not changing. Correct?
Yes,
This
ma'am.
is going to be fixed. Even if you even if you your demand is 550, this is going to be fixed. This is not changing. This is fixed. Right? Even you manufacture 550 products, this is going to be fixed. This is something which is getting like vary basically because it is per unit cost it is given. Right? So this is a variable cost. Right answer. So now, how do you simulate this? Okay, so I have prepared a data. So this is little bit going technical, no problem, right? Okay. So let's say I have taken the cost. So administrative cost is 400,000. Then advertisement cost is 600,000. Labor is 450 per unit and parts is 1,000 per unit. I have just put the data as it is. Selling price is 3,500 per unit. Okay. Now it is given that mean of population is 500 and standard deviation of population is 50. Right. Now what I am calculating here, operating income. So in the slide which we have seen, that you can calculate the operating income, like simulate with random probability in the context to understand how fluctuation in demand impact operating income and other key metrics. Okay. So other key metrics, what can be the other key metrics? I have given some following slides. So that is a homework for you guys to do. So you can actually practice on this. So I have calculated the operating income, which is simple to calculate. So I have done it. Okay. So now let's see. So basically it is following a random distribution. It is said the demand is following the random distribution. So what does simulation mean? Simulation means you are repeating something. Okay. You are repeating with different probabilities of that demand. Okay. So we will take some random probability, and probability can be the number which is from 0 to 1. Any number from 0 to 1. Right. So we are repeating with n number of probabilities, 5,000 times, 10,000 times. So here I think it is 5,000 times being repeated. Kind of 5,000 times it is repeated. You can see if I count is 5001. Okay. So based on your repetition, actually you can check that whether every time you are simulating the data is coming correct or not. Okay. So kind of what is a closed data or what is a deviated data, or like how much, like if the deviation is there, how much is the deviation. So let's say for first time it came like 598 for the break-even point. The next time you simulate, it came as 599 for the break-even point. So you have a like a kind of a vision that okay, like data will be falling in this category only every time for this break-even point. So kind of it is kind of, so maximum times you iterate, so more like more close you will be to the actual number. So this is how actually it is predicted. Okay, so now I have taken some sample. It's a random number. Okay, forget this column. So this is not relevant basically. And this is a random probability. So I have taken a rand, basically a formula. So this is every time it will simulate, it will take a different random probability. Based on the random probability, I have calculated demand. So demand is basically something which is falling from 500 to 50, like plus minus 50. And with this given probability, so this is the basically the formula to find out, because it is following the normal distribution. So for the normal distribution curve, this is the formula. So you can see what are the like sale value I have used. This is the probability. So the first one is a number, which is a probability. So if you just put here, like after this normal function, probability, mean, and standard deviation. So this is a probability which is getting simulated for n number of times. This is a mean, and this is a standard deviation. Okay, so I have just put that in the formula to calculate the demand. Okay, and now the operating income. So operating income formula I have already given in the slide. So it is a total revenue minus total variable cost minus total fixed cost. Okay, so total revenue is how much? Total revenue is selling price. It means 3500. So you can see, if you see this formula, I will explain this. So first one is E2. Okay, E2 is selling price per unit. Okay, into C8. C8 is what? This demand. So whatever demand is coming with different probabilities. So total revenue is your selling price into, like, the number of units will be your demand. So if 482 demands have come, that means 482 units you have to manufacture. So this is your total revenue minus total cost. So total cost means total variable cost plus total administrative cost. So first, total administrative cost. You can see these two. This is a variable cost. So basically 450, B4 is 450, and B5 is 1000 into C8. C8 is again my demand, like number of units getting manufactured. So this is my total variable cost, and total administrative cost is these two. So minus these two. So this is giving me the formula of the total operating income, right? So this I am simulating for n number of times. Okay. So this I am simulating for n number of times. Same formula only. Okay. And I am just trying to see that, like, what will be my, like, in which demand I will get some profit, and what will be my profitability. So operating income is nothing but your profitability here. So that is how, like, you calculate the risk. So there are two more terminology actually that is called, like BAD and CVAD. Okay. So these I won't explain in today's session, because these are something different thing, like some different calculations we do to, like, calculate the risk factor basically. Okay, so this is mostly, like now if I simulate, so a macro is basically written here. So if every time I run this simulation, so this will simulate and give me the operating profit. So that very way I can understand wherever I will get zero, I will know that that is my break even point, that I will have neither profit nor loss. Okay, wherever I am getting negative values, I know that these are the points. This is a demand where I don't have any profit. I will see the losses. So this is a good prediction which it gives every time, like you simulate, and kind of you can actually like hold this data and check that how, like, what is that point where you are getting that break even value. Okay, so because after that anything it will give you the profit only, fetch you the profit. So that is how actually Monte Carlo simulation, with the simulation you can forecast the demand in supply chain. Okay, so this is one example actually. It is a simple one. Another one I have done, but this is really complex one. So I'm, like showing this here. So this is a complex problem. So this I had done before only, like in one of my work. So this is also, if I simulate, kind of it actually changes all the data. Like number of times it actually simulates. So any questions on this?
No.
Okay. Guys, I have given in the slide, you can see that there are certain other key factors which you can actually, like forecast given like with this simulation. That is break even quantity. So that is a point at which, let me just put it in the slide. The point at which total revenue equals total cost, meaning there is no profit or loss. That is what I said. Contribution margin. So these are different measures which you can calculate, and the formulas are given. So anybody wants to try with this simulation only, they can actually go with it, just putting the formulas. This measures the difference between selling price and variable cost per unit. Then gross margin. By focusing on gross margin, you can determine how much revenue remains after variable cost. Okay, so these are different formulas basically, and different key factors which you can calculate in the supply chain. Cost per unit of demand. This examines the cost efficiency related to the demand. Then operating leverage ratio, OLR. By understanding the operating leverage, you can gauge how change in sales volume impact operating income. So these are the different parameters actually which will help you to take the decision. So I am expanding on the analytics side, kind of, like what kind of demand will actually give you some break even, how you will calculate the contribution margin, what is the operating profit, what is the gross margin. So all these things you can calculate in a supply chain network. So with this, I will end this session. If any questions, just ask me. Otherwise, yeah, we will have this session live also in YouTube and LinkedIn. So anybody wants to refer to the Excel which I have created, that is actually containing some macro code. So just mail me. I will provide that Excel. Like anybody interested to, like to dive, like deep dive into it, I can provide that Excel. Any more questions?
No from my side.
Okay, thank you so much for attending this. So in the next workshop, we will really do some data analytics, like from starting from, like how to kind of do the EDA, what kind of data type, like data structure of the data, which is, like which we can see in supply chain network. And probably, like we will little bit, like dive deeper into the, like the analytics section. It will be more technical. Today, it was more kind of a giving an overview. It will be more technical how we can, like take certain decision based on the analytics. So maybe it can be the route decision or, like inventory decision. So I think that will be useful. So I hope I could give you some insight. So thanks all for joining today.
Thank you.
ma'am.
Thank you.
so much.
Thanks for the session.
Thank you, ma'am.